Alright, so this is section 1.3. We're going to talk about factoring, and we want to define what a factor is. We want to be able to find the greatest common factor. We also want to be able to factor quadratics, which we're going to do more of later in chapter 1. And then obviously hopefully we don't confuse everyone too much. Okay, so first let's talk about factors and what they are. So factors are a set of numbers that can be written as a product of a certain number. So for an example, we have 18. That would have factors of 1, 2, 3, 6, 9, and 18. And also their negatives are considered to be factors, though we won't use those a whole lot. And the reason that these are factors is because I could write 18 as 1 times 18. I could also say that it is 2 times 9. I could say that it's 3 times 6. So these are all factors because I could use them to multiply together and have a result of 18. Now, my process for finding the greatest common factor. So the greatest common factor is the largest factor that 2 or more numbers have in common. Okay, so for number 1 with 3 and 15, I could write 3 as 1 times 3. But that's my only way, or that's the only way that I could break down 3. But 15, I could say that it is 1 times 15. I could also say that it is 3 times 5. Okay, so now I want to look for the value that is the largest between, or that they have in common, and that would be 3. So my greatest common factor for number 1 would be 3. I can apply the same process to 12. So 12 would be 1 times 12. I can also do I can do 2 times 6 and 3 times 4. Okay, I do the same thing for 16. So 16 can be written as 1 times 16. Can also be written as 2 times 8. And it can be written as 4 times 4. And then for 24, I can say 1 times 24. 2 times 12, 3 times 8, and 4 times 6. And so I don't have to take them any farther. So if I look here, then my greatest common factor would be 4. And we use factoring a lot when we're simplifying polynomials. So simplifying just means that we have factored everything as far as we can factor it. So basically we've pulled out or we've undone the multiplication of our terms as far as we can. So using that process that I did on the previous slide, I can say, okay, well, 12, again, is 1 times 12. It is also 2 times 6, and then it is 3 times 4. Okay, so doing the same thing for 18, I have 1 times 18. I have 2 times 9, and then 3 times 6. So if I look here at my factors, then 6 is my greatest common factor between these two. So I'm going to pull the 6 out. Okay, so since it takes 6 times 2 to make 12, I still have a 2 left over. I didn't do anything with the p, so I leave the p alone. To make 18, I have 6 times 3, so then I have 3 left inside the parenthesis and q. So I'm undoing the distributive property is what I've done here. So if I wanted to check myself, I could just apply the distributive property. 6 times 2 is 12p minus 6 times 3, which is 18q. All right. Now for the second example, using that same process that I just did with both of these numbers, I would find that my greatest common factor is 3, but also I have an x in common with both. So I want to go ahead and pull out that x. Now, it takes 3 times 2 to make 6, so I still have a 2 left over, but I have pulled one of these x's out. So I have 2 x's here because of the x squared. I've pulled one out, so I still have x left over. And then for my second term of 9x, I've pulled the 3 out, which leaves me with 3 times 3 to make 9. And the x that was here, I had 1 x here, so I pulled it out front. And so now that is all that I have left inside the parenthesis. Again, undoing the distributive property, you can do this. You can check with the distributive property. The same process works no matter how many terms you have. You could have 2 terms, 3 terms, 4 terms, and so on, and you could do the same thing, and all you're trying to do is find what they have in common, and that will allow you to factor out. Alright, so now when we factor quadratics, so this is something that I feel like students sometimes struggle with, and so I hope to make it as simple as possible. I'll also attach a video to Khan Academy that explains a few different situations that you can try out. Alright, but if you think about it, when we are factoring, again, as I mentioned on the previous slide, we're undoing the distributive property. Okay, so what I have here is we're trying to get this written in the form of x plus a and x plus b. All right, so using the FOIL method and distributing this twice, all right, I have x times x, and then, so that's x squared, plus, all right, I'm going to do x times b plus x times a, so that's basically a plus b times x plus ab. Okay, so now I have my general form of what it's going to look like, right? This is the same, what I have written here is the same form as our x squared plus 3x minus 10. All right, so we want to talk about a and b. All right, a and b are going to multiply together to make negative 10, and a plus b has to make 3. So we want to discuss possibilities of a and b. Okay, since the sign for the third term, or the 10, is negative, that tells me that I'm going to have different signs in my a and b. Okay, so let's talk about possibilities. So possibilities to make negative 10 with different signs, I have negative 1 and 10. I also have 1 and negative 10. I have possibility of negative 2 and 5. And I also have the possibility of 2 and negative 5. Okay. Now I want to look through my possibilities and see which one, when I add them together, makes positive 3. So if I were to add negative 1 and 10, I would be left with 9. That doesn't do me any good. If I add 1 and negative 10, that leaves me with negative 9. But I have negative 2 and 5. If I add those together, I do get a positive 3. So that would be my choices for A and B. So all I have to do is replace A and B with those values. So I have x minus 2 and x plus 5. Okay. So that is how we factor quadratics. This is a process that we're going to use several times later in the chapter. So be sure to have a good grasp on this. You can test out all of these possibilities if you're unsure. but this is the general basis of how it works. I'll attach a video to Khan Academy too that goes into, or that maybe shows you a different way, but this is the basis of factoring quadratics. Okay, so now I want to show you just a few forms of special type quadratics. So the first one we have is a difference of squares. So if we apply our FOIL method, I do x times x is x squared. And then I have x times negative y, so negative xy. I have a positive xy because of my y times x. And then I have y times negative y, which would be negative y squared. My middle terms are negative and positive are the same, so they just reduce to 0. So I have x squared minus y squared. So that would be deemed a difference of squares. Now I have x plus y squared. These are called perfect squares, where we just take the same thing and we square it. It means we multiply it by itself. And my final result would be x squared plus 2xy plus y squared. And then for this one, I do the same thing, x minus y times x minus y. And I have x squared minus 2xy and plus y squared. These are just some special cases of quadratics. If you recognize them, great. If not, it's okay, because we can just factor and undo what we've already done, or undo the distributive property, or distribute and figure these out. But if you notice them, great. If not, it's no big deal. All right, so this concludes 1.3. I know factoring is something you've seen before, but hopefully you don't have any issues. But if you do, as always, please feel free to email me, and have a great rest of your day.